I'm going to begin with something a bit pedestrian, but we, of all people, are still mucking this up, and it's just going to get worse in the future if you take this approach with other kinds of questions. This is a proof. You're given a left-hand side and a right-hand side. You must start from one side or the other and get all the way to the other side, right? If you need to employ some other techniques where you manipulate both sides in order to try and help you see what's going on, that's fine. But to prove, you should go from one to the other, and you certainly should not start with that as your first line. That's like kind of putting a gun to your head and pulling the trigger in terms of proof, okay? So let's have a go at this. Now, which is why I'm raising it. You remember we had a look at trig identities, right? Trig identities. And we said to prove one side equals another, usually the way we start is with the more complicated side, and you simplify until you reach the simpler side, okay? I don't know, I don't have a direct answer for this. Maybe one of you can tell me after I finish explaining why this is the case. My brain actually tends with these questions to go in reverse, and I'll show you why. Let's have a start with the left-hand side. This is where I'm going to begin. And what I want to think about is what should I apply to this in order to get it closer to the right-hand side. And the right-hand side gives you some big flashing clues, namely these guys, right? There's a change of base taking place. So automatically you know I have to do something to change that base right away. Nothing else I do matters until that is done. So what I did was I thought, okay, I can express this all in terms of base 2. That's easy, right? Just the standard change of base law, which is the x is on the top, so it's going to stay on the top, log base 2 of x. The 6 is on the bottom, so it's going to stay on the bottom, log base 2 of 6. Okay, now this is a fantastic step because you can see I've already got my numerator in place. Now to move from here to here, I admit, and this is part of the design of the question, the 1 kind of spins people out a bit. They're like, where on earth can I possibly get that 1? Now, being that this is what I've got at the moment, it clearly must come from a log, right? It must come from a log somewhere that gets simplified into 1, right? Think about, we've used change of base law. What's the log law that converts things into 1? 1's equal to log base A of A, right? To raise something, right, to whatever power to get itself, that's log base A of A. So therefore in here, being that I've just converted everything to base 2, these guys are in base 2, I'm expecting a log base 2 of 2, somewhere in there. How do I get it? Someone want to suggest? Yeah, Doris.
If you split the 6 into a 2 times 3.
Yep, fantastic. 2 times 3, there you go. I agree. Now, by the way, this is a show question, so even though this step here it seems relatively trivial, I think it's valuable. I put it in my solution, as you can see if you're looking at it. Once you've got this, then you can convert it to 2 logs, right? The product becomes a sum. So you've got that log base 2 of x. Don't go straight to the 1. You've been given that it's a 1. So you can't use that as part of your argument, right? That's got to be where you finish. So I'm going to go to here instead. Okay. Minor difference, but it's the difference between trying to show that the burden of proof is on you rather than just using what you've got in the question without understanding it. And now I can state the right-hand side. Okay, as required. Does that make sense? Any questions on that one? Okay, so like I said, little things. Most people were sort of headed in the right direction, but they missed some minor points. Let's have a look at this guy. In some ways, going in the opposite direction. Okay? You've got to start with this. That's all you know. Okay? So I'm just going to write that down. Okay? Now, help me out. What log law am I going to use to combine this to get closer to what I'm required to prove? That's it. Fantastic. So just like the opposite of what I did here, you can see different log laws are being tested. Hey, by the way, if you're having a conversation, that's great. I'm confident, looking at the conversations that you're having. I think they're good conversations, right, Jinsu?
What?
Exactly. If you cannot have your conversation in a way that's quiet enough so that you can still pay attention and not disturb others, then do not have it. Wait till the time is appropriate. Okay? I don't mind you having the conversation if you can have it quiet enough to actually hear what's going around you, but Evidently you're struggling. This is the product rule, in a sense. This is the quotient, right? So, as Minsu suggested, you've got the fraction there. And now that I have everything in terms of one log, I can convert from a log equation to an additional equation, right? An exponential, as it were. So what have I got here? What am I going to have as the subject? What would you make the subject? 2, that's the base, to the x, right? And that's where you can see this coming up, right? Of course, over here, I've got that, and now algebra takes over. You've done the log part's out of the way. All you need to do is make y the subject, which is not difficult, right? This is going to be 2x minus 2 to the x. Y, I've just multiplied the 1 minus y across. There's my 1 plus y there. And now I just need to gather my y's and gather my x's, right? So let's see, I'm going to have, I'll add that over. So I'm going to have 2 to the x, take away the 1, and I'll have 2 to the xy plus y. Is that okay? So I just have my order matching up nicely. This is already the way that I need it. Over here, I just need to factorize, right? So there's that there's that y. I bring out the front. And that means I'm only one step away from making y the subject, right? And I'll do that all at once. Keep doing that. Okay. Now, just a footnote before I answer your question. This is really important. Don't pull any punches on this. When we move further into the HSC course and we meet a topic called inverse functions, right? This manipulation of like sort of going from this being the subject to this being the subject, it's a critical skill.